the second part of the differential or the integration they've got in section 7.4. I'm calling it 7.42, and they're about using this algorithm of a pattern that's seen commonly. Similar to the previous one where we've got the integral of some value k of f dash x over f of x. It only works if this pattern exists and there's no extra x's around. So this has the same problem. Substitution, I feel, is a little easier, but I'll show you both methods, substitution and their method. So we look at the equation and we're looking at something there. We're saying, well, I'm going to need to differentiate my function u. So I'm looking for a function u, and when I differentiate it, it becomes either a constant or something that's elsewhere in here. And the u and the du dx must get rid of all versions of x. So if I start with cos of 3x, this part in the bracket, and I differentiate it, differentiating cos gives me minus 3 sine x. Rearrange it so I know what dx is. So dx is du over minus 3 sine x. So I'm going to substitute that in and do an integration based upon it. So when I do the integral, I've got the integral of 5 sine 3x. I haven't managed to replace that with anything here yet. But the cos x now becomes my u to the 4 with respect to, and instead of dx I want du, the dx to change to du, so it becomes the du over minus 3 sine x. And this is the magic part with this. The sine 3x's, because this is the differential of this thing inside the bracket, which is what's assumed over here, they will cancel. So now what I've got is I've got the integral of minus 5 over 3 u to the 4 of du. Now when I integrate this, just need a little bit more room. So when I do the integral, I'm going to get minus 5 over 3 u to the 5, and then divide through by 5, 1 over 5, because of the integration and a constant c. And this means I've got minus 1 over 3. The u to the 5 is cos 3x to the power of 5 plus the same constant. So that's using substitution to integrate this. If I go to using their pattern, they've got a section in here where they don't know how to deal with this k, and you do it by matching terms. Other than that, it's actually quite simple, similar. So they say, I know that my function inside is cos 3x. So say fx is cos 3x. The guess is that if I integrate this to give me my function e, my value I, the I is going to be some constant k still times the, or some coefficient k, times some adjustment we've got to make. So the k in this case was 5, sorry. Let's remove that and put 5 in. So we've got, but they don't know, and they're making a guess. So we're going to guess that the answer to this is our constant 5 times some value I've got to work out, and then they take the function itself, fx, which in the same case is cos 3x, and we try 1 power higher. So instead of having the cos to the power 4, we try cos to the power 5. And what we're going to do is use differentiation of this function to see how does it match to this pattern? So we're going to differentiate I with respect to x. So we get the 5a. We've got a function here inside, so again we're going to use the chain rule. U equals cos 3x du dx is 3 cos 3x. So we get the differential of u cubed, so we need to differentiate with respect to u to the 5, and multiply by du dx. So this is the chain rule. The 5a stays constant. This is the thing that they don't know how to find, so they're going to do it by matching to the original equation. So we've got 5a and du. So du to the 5 is, actually they didn't need the 5 in front of this. Let's lose the 5s. We just need to know there's a constant in front. The k there would have is going to appear. You're going to see the k appear in a minute anyway. So we now do the integral differential of that, which is going to be 5 u to the 4. Du dx is 3 cos 3x. Differential of cos, it's not cos, it's sine. Differentiate cos, we get minus sine. In fact, so I'll just rewrite that last line. So a is the constant we've still got to work out the value of. 5u to the 4 is the differential. So that comes from the differentiating the u to the 5. Multiply by du dx, which is times minus 3 sine 3x. So evaluate our values. We've got a times minus 15 is u to the 4 times sine 3x, and that part there is my cos 3x to the 4. The thing that was in the top of the differential. Sorry, my pen's just moved away from the main screen. So now what we do is we compare to the operation up there, and we have the sine 3x, we've got the cos 3x to the 4, which came from here, so that bit's found, that bit's found, that bit's found. And what we've got is we've got a dot minus 15 must equal 5, so a equals minus 1 over 3. And therefore we can then put it back into our original trial at the top here, that the integral I is now minus 1 over 3 cos 3x to the 5 plus some constant. And that was the assumption. That needed strictly should have had a constant on the end as well. Okay, personally I prefer the substitution method for this, but that's the method that they are showing in the book as well.